Limnic eruptions, a phenomenon often overshadowed by more visually dramatic natural disasters, represent a unique and terrifying threat. These rare events, also known as lake overturns, involve the sudden and catastrophic release of massive quantities of dissolved carbon dioxide, CO2, from the depths of certain lakes. The resulting invisible cloud of gas can suffocate humans and animals, leaving behind a chilling silence in its wake. While only 2 major limnic eruptions have been recorded in modern history, the potential for future occurrences in susceptible lakes around the world demands our attention and understanding. The genesis of a limnic eruption lies in the unique chemical and physical characteristics of certain lakes. These lakes are typically deep and stratified, meaning their water is layered with distinct temperature and density differences. The bottom layer, often anoxic, lacking oxygen, can accumulate high concentrations of dissolved CO2 originating from volcanic activity or the decomposition of organic matter. This CO2 remains dissolved due to the immense pressure exerted by the water column above. However, this delicate balance can be disrupted by various triggers. Earthquakes, landslides, or even significant changes in weather patterns can agitate the lake, causing the CO2-rich bottom waters to rise and mix with the upper layers. The consequences of this mixing are dramatic. As the pressure decreases, the dissolved CO2 rapidly exsolves, transforming from a dissolved state into a massive gas cloud. Because CO2 is denser than air, this cloud hugs the ground, flowing outward from the lake and displacing the oxygen necessary for life. The invisible nature of the gas makes it particularly dangerous, as victims may not realize they are in peril until it is too late. Asphyxiation occurs quickly, leading to loss of consciousness and death. The scale of these eruptions can be devastating, as demonstrated by the 1986 Lake Nyos disaster in Cameroon, where a limnic eruption released a massive CO2 cloud that killed an estimated 1,700 people and thousands of livestock. The rarity of limnic eruptions makes them difficult to study and predict. Identifying lakes prone to such events is crucial for mitigating future risks. These limnically active lakes often share certain characteristics. They are deep and stratified, possess high concentrations of dissolved CO2 in their depths, and are typically located in areas with volcanic or geothermal activity. Monitoring these lakes for changes in CO2 levels, water temperature, and other indicators can provide valuable insights into potential triggers and help in developing early warning systems. While the threat of limnic eruptions may seem remote, the potential for catastrophic loss of life underscores the importance of continued research and monitoring. Understanding the complex interplay of geological, chemical, and meteorological factors that contribute to these events is essential for developing strategies to mitigate their impact. By acknowledging the silent killer lurking beneath the surface of certain lakes, we can strive to protect vulnerable communities and prevent future tragedies.